So as I showed, there are three ways to solve these systems. We have graphing, substitution, and elimination or addition, as it's sometimes called. And I just want to show you the three different ways on the same system and show you that they get the same answer. It's just whichever one makes more sense. Of course, graphing I think is the most simplest. It's also the fastest. But sometimes graphing doesn't give you the exact answer and you need to use the algebra to solve for it. So graphing, this first one, right, we just take the two lines here, the two relations, and you graph them. They do end up being two lines, and they are actually functions. But the point we're looking for is the intersection point. If you have a true statement, as I showed you before, then the two lines are going to be overlapping on top of each other. They intersect infinitely many times. If the two lines are parallel, however, they never intersect, so there will be no solution. Most of the time, however, you have two lines that do intersect, and they will intersect at one point. Or for different systems, you may have different kinds of relations that cross the lines, and they can intersect more than once. But for these ones, we're going to be looking at systems of linear equations, and these will only ever cross at one point if they are intersecting lines. Of course, here they cross at the point negative 3.6 and negative 1.4, and that is our solution. These could be perpendicular lines. Perpendicular just means that they cross at a right angle. That doesn't really matter though. They're still intersecting, and that point is still the solution to the system. So like I said, this one's quite easy. You just look at the graph and boom, you have your solution. Now for this next one, let's solve this via substitution. To do substitution, as I've shown before, you need to have a variable solved. In this case, I can solve quite easily the top one for x. I'm just choosing that one to solve. I can solve for y if I want, but that one looks the easiest to me, so I'm going to go for that. And all I have to do to solve for x is just divide by 2 on both sides. So we get x equals 3y minus 3 over 2. And now if x equals that, then all I have to do is plug this or substitute it in for this x in the other variable. Make sure you plug it into the other variable, or sorry, other equation. You have to use both equations to solve a system. If you only use one equation, then you're actually going to always get a true statement, and it's not going to be helpful. Okay, plugging into the other equation, we get 1/2 3y minus 3 over 2 minus 2y equals 1. And I can multiply these two things together, giving me 3y minus 3 over 4 minus 2y equals 1. To get rid of the fraction, I'm going to multiply everything by 4. That will get me a nicer equation to do. The first one is just going to be 3y minus 3. This is going to be minus 8y. And this is just going to be 4. Okay, combine like terms. I get minus 3 minus 5y equals 4. Getting the y by itself, divided by negative 5, I get y equal to negative 7/5, which just so happens to be negative 1.4. So the same thing we got here for the graphing. Now all we need to do is figure out what is the x value. Well, if y is negative 1.4, that means this y is also 1.4. So I can substitute it in. It's 3 minus y minus 3 over 2. Of course, y here is 1.4, so let me plug that in. 3 times 1.4 is going to be 3 and 1.2, so 4.2, negative 4.2 minus 3 over 2, negative 7.2 over 2. And doing that will give us negative 3.6. So same exact point, negative 3.6 for x, negative 1.4 for y. That is our solution using substitution. So once again, solve for one of the variables. Doesn't matter which one, just solve for one. Once you do that, substitute it in the other equation, and then solve for the variable, and then substitute that back into. You can use either equation at that point, but just substitute the value of that one variable in, plug it back in, and go from there. I personally like elimination the most. I think it's the fastest once you really know what you're doing, but it requires a certain setup. You have to make sure the columns are all set up. Here, the columns are not. They look like they are, x's, y's, and number, but the equal signs are not the same spot. So you have to make sure that the equal signs are. And I can do that quite easily by just subtracting 3y to the other side. I'm going to move that down here. That's going to give me 2x minus 3y minus 3, equals negative 3. And now you can see that the x's are all lined up, the y's, the equal signs, and the numbers. So I can go ahead and do the elimination process. You need to choose one of the two variables to get the same number in front but opposite signs. It doesn't matter which one, just choose the one that looks the easiest to you. For me, either one really looks pretty easy to do. I think actually the x's might be a little bit faster, however, because if I multiply this top equation here, this 1/2 x minus 2y equals 1, if I multiply everything in there by negative 4, then that will give me a negative 2x, which is the exact same number but opposite sign as this one. So I'm going to go ahead and do that. I'm going to multiply everything on the top by negative 4, and then write that down here. Negative 4 times 1/2 is going to be negative 2x. Negative 4 times negative 2y is positive 8y. Negative 4 times 1 is negative 4. Now you can see that the x's are the same number, opposite signs, so when I add these two equations together, they cancel. And that's what I'm looking for. Of course, we have negative 3y plus 8y, it's going to be 5y. And negative 3 minus 4 is negative 7. All I have to do is divide by 5, and I get y equal to negative 7/5, which is the same thing as negative 1.4. Now at this point, I have to do the same process as the substitution. I need to plug y equal to negative 1.4 into one of the two equations. Doesn't matter which one, you'll get the same thing. So I'm going to plug it into the bottom equation since I plugged it in the top equation the last time. I'm going to plug in the bottom equation. And that's going to give me 1/2 x minus 2 times negative 1.4 equals 1. This is just a linear equation of one variable. Get x by itself, and we're good to go. I'm going to change this fraction to 0.5. It's a little bit more, 0.5. Because we have fractions and decimals, it's not really nice to have those two things in the same spot. So I'm just going to keep it all the same type of number. This will become plus 2.8 equals 1. I'm going to subtract 2.8. It's going to give me negative 1.8, then divide by 0.5. Dividing by 0.5 is the same thing as doubling it, but just use a calculator, and you're going to see we're going to get negative 3.6. So once again, y equals negative 1.4, x equals negative 3.6. The same answer, no matter which way I do it. Now, real quick, I want to show you using this elimination method by getting the y's to be the same instead of the x's. Let me get that set up here. Okay, this is the system that we had. Once again, I lined up the columns, and what I did is I multiplied, the previous time I multiplied the bottom equation by negative 4 so that the x's cancel. However, you can multiply and get the y's to cancel as well. In this case, you're looking for what's the thing that I need to multiply each equation by, because you can, but it's going to require a decimal. You can multiply one of them by a decimal to get this, 3. For instance, the bottom equation by 1.5. But I like to use whole numbers and not decimals. And all I'm looking for there is what number can both 3 and 2 go into, and that's 6. So if I can make both of these 6, then I can cancel the y's out. So this top one, I'm going to multiply by 2, everything by 2. The bottom one, I'm going to multiply by -3. I could also do -2 and +3. It doesn't really matter. I'll just do this. You need to have opposite signs. Just choose one to do it, whichever may come across to you as easier. We have -4x plus 6y equals, let's see, it's going to be 6. Then we have 3/2 x minus 6y equals 3. Adding it, the y's cancel. 3/2, I'm going to write this as 1.5. So minus those is going to be -2.5x equals 9. And then dividing it out, go ahead and do that. 9 divided by 2.5, yep, is -3.6. We get the exact same number as you would expect. So there's lots of different ways that you can do this. Just find the one that makes the most sense to you. Give it a try in number 1. All right, so the next one is, are any of the points solutions to this system? This one, and this point here. Well, let's go ahead and try this. To see if it's a solution, we just plug them into the equation. So x here is 4, y is -5. Let's plug into the top. X is 4, y is -5. Okay, 5 times 4 is 20. Minus, that's going to be plus 10. And we get 30 equals 28. That's not true. Therefore, we know that 4/5 cannot be a solution. Okay, let's try the next one. X equals 6. Y equals 1. So 5 times 6 minus 2 times 1 equals 28. 5 times 6 is 30. Minus 2 equals 28. 28 equals 28. Perfect. However, we need to check both equations. So bottom equation is 3 times 6 plus 6 times 1 for y, and then equals 3. 3 times 6 is 18. 6 times 1 is 6. That gives us 24 equals 3. No, 6, 1 is not a solution to this system. For the last one, let's go ahead and graph this system and see what we get. And you can see, yeah, that definitely looks like a solution to the system. However, if we zoom in, it's actually not. So the solution to this system, of course, is just click on here, and Desmos will find the solution for you. In this case, it's going to be probably an infinitely long, these are probably 2 rational numbers, 8.33333, and then -1.91666666 all the way on down. So this is a pretty close estimate, but not close enough. Just for reference, I want to show you what the other points look like. Down here is 4.-5. You can see that didn't work for the first equation we tried, and it wouldn't work for the second equation. This one here was 6.1. This did work for the first equation we tried, but it did not work for the second. It has to work for both for it to be a solution. That's the reason why we have to zoom in, and we can see that that is the only solution to this system. Give it a try in number 2. All right. This is a pretty classic type problem using a system. It's something where you have a mixture of different quantities, whatever it is. So here we have a 10% saline solution, or something that's got salt in it, with a 60% saline solution. and we want to have 25 gallons of 40% saline solution. So how many gallons of the 10% and 60% should we mix? Of course, if we mix the 10% and the 60%, it's going to dilute the 60%, and we want to dilute it to a 40% overall concentrated solution. So how do we do that? Well, we can use a system to define this, and really we want to have two variables, and the two variables that we need to know are how many gallons of each percentage solution should we mix. Well, I'm going to give us variables here. I'm going to give us G10. That stands for gallons of 10% solution. So gallons of 10% solution. And then G60 is gallons of 60% solution. And now, using this information, we're looking for two equations. We have two variables, so we need to have two equations to solve for an exact quantity. That's typically how it works for a system. If you want to solve for a solution, you need to have as many equations as there are variables. So the first one I can get out, it may be a little confusing, what can you get out? Well, if we read this thing, we have 10% saline solution and 60% saline solution. We pretty much can assume we have unlimited quantities of those, since it doesn't give us a restriction. But we want a specific quantity of this. We want 25 gallons of 40% saline solution. That's the key thing here. 25 gallons of 40% solution. So if we want 25 gallons, then we know that however much we mix, there's nothing else coming, there's no gallons coming from anywhere else besides the 10% and the 60%, which means if I add the gallons together, this has to equal 25, because that's how we're making the 25 gallons. We're combining these two gallons of these two concentrated solutions. Now we've figured out the gallons. Now the only other piece of information we know is the percentages. Well, we can think of this kind of as like if 10% of saline solution is, and we have G gallons, G10 gallons of it, then that means 10% of this will be kind of the gallons of salt in the 10% solution. So what I can do is I can take 0.10 times G10, and this is how many gallons of salt from G10. Likewise, if I mix 60%, the 60% solution times G60. So for instance, if I had 10 gallons of G60, then that means 6 gallons of it is going to be salt. And the rest is going to be, that's kind of a very simplistic way of thinking about it. Gallons of salt from G60. And of course, we want to have 40% of 25. So that means we want to combine these two things and get 40% of 25 gallons. So this is going to be gallons of salt desired. But of course, 40 times 25, well, that we can actually calculate. That's going to be 10. And this, you can see, get rid of all this information. This is a system of two equations. We have two variables. We can solve for an exact quantity for each of the variables. Okay? Doing this, I feel like we can just, substitution. We could graph it. We could do lots of different things. I'm going to solve this using elimination. I think there's a good way of doing it. Of course, I've shown this with the mixed nuts and peanuts before, how to solve this thing with substitution. Let me solve it with elimination just to give you another look at that. I'm going to multiply the bottom one by 10 so that I don't have any more decimals here. That's actually going to give me 1 here, 1 G10. So I'm going to actually multiply it by negative 10 so I get the same variable but opposite signs. It's going to be positive G10, it's going to be negative G10. And then all the columns are lined up, so we're good to go there. Let me just write that down again. We have the top equation the same. The bottom equation, negative 10 times 0.10, it's going to be negative G10. Negative 10 times 0.6 is going to be negative 6 G60. And negative 10 times 10 is negative 100. And now I can add them going down. Those, of course, cancel. G60 minus 6G60 is going to be minus 5G60. And 25 minus 100 is negative 75. All I have to do now is divide by negative 5. And I get, we'll do it up here, G60 equals, that's going to be 15, 30, 60, yeah, 15. Okay, well, if G60 equals 15, G10 must be what plus 15 equals 25? G10 has to be 10. And these are, of course, gallons. That is the amounts that we should mix to get the 40% of 25 or 25 gallons of 40% saline solution. All right, give it a try in number 3.